So I want to create the new process that execute the PS command. What is a PS command? It's a process list that you tested the last time. Well, this one is my process is the BA, bash shell. So currently, after forking, the children process has the bash shell code, cross shell, and data copy, stereo copy, exactly copy. It's a clone of me. Then second step is the EXEC. EXEC means we have the PS instruction where hard disk drive. It's an executable file, and copy this instruction to the children process, and then separate. Then finally, children code has a PS. This one is a bash shell, and this child has their own data, their own stack, their own the heap area. So two steps, fork and EXEC. These are the most popular, actually the interview question when I look for my job 20 years ago. But still important, still use the same mechanism. So fork and EXEC. Because of that, most of all the operating system provide system call fork function and EXEC function. But slightly the variance. They support a little different function. So sometimes we fork, we EXEC, or EXEC, we, or fork, we, something like that. But you should be able to understand each and every the system code. Okay? How can you find that information? Manual. Do you remember the man, time, fork? Then you will see all the info. Or you can search the Google. Or you can, if you have the Linux, the operating system group, it's okay also. So that is fork and EXEC. What about your program? Have you ever used the fork and EXEC directly? Probably not. Why? Your operating system automatically, when you type, your, for example, operating system provide the bash shell, BASH. BASH, bash shell, actually knows how to create. Okay? If you type the command and fork, first submit the fork, then assign the command code to the code of the child process. Okay? That's your job in your project A. First project, you need to implement a program that can fork, execute the fork, then assign the EXEC, then with the assignment of the programming code of what? That you enter. Okay? Input. That's it. That is the main job of the project A. Okay. What about the Windows? Have you ever seen the fork and EXEC? No. Somebody complain. If they are working as a pair, why don't we combine? So Windows API provide the new system called create process that include automatically fork and EXEC. But actually, basically, you can separate the two system code. Okay, so these are the diagrams to show the so fork. When a process executes the fork, there's a parent process, okay, still there, and child processor. This time they are sharing the code, everything. Okay. Then after EXEC, okay, EXEC, its own data instruction will be copied and separated, but not entirely disconnected. It still has parent and child relationship. Then once the child is done, they can submit the exit, is the termination. Then parent process here, whether I'm always worried about whether my children are safe or would like to hear their news or whatever. It's the same thing. Process, parent process, wait until child process is done, which means EXEC. Then this child process, life of the child process is done. Okay, then parent process can resume their own job, and you can submit next process, next comment, something like that. Okay. So this is an example of the SQL that probably you need to use in your, basically this concept in your project A. Later, fork. What is the return of? How do I know? Return of the fork is what? Check your manual. Okay? Manual and the other, the system programming research. This is a very well-known program. Okay? What time is it? 4 morning. Okay, so this is a fork. That is this state. That is this state. Okay? They create the new area, but they are the same, identical. Even data part is shared. So then, check PI whether this return code is less than 0, whether it's 0 or the S. Okay? That indicate the specific status. Sometimes you cannot create the process. For example, you do not have enough memory space to create a child process. So there should be return code less than 0, either -1. That's the fork phase. Otherwise, you can successfully create the process, but it's same as mine. So you can assign the ls command that somebody typed. So in your program, you need to read the input of this one and run the exec. Okay, then that's it. Very simple. So you can do the same thing in your project A, but your program should satisfy with the several the requirements. This is an example of the Windows API. It's the same idea, but they are using create process. It's combined the fork and exec. But it's the same idea. So after we create, you can see such a list of the processes. So you can use the command the PS, an option with the EF and the pi. Because it's more than 1 pages, so you can use the pi. So read the more. This one shows the hierarchical structure of the Unix processes. You can see for example, in my case, so this current one is on the D3. This is the P3 command. Not P3, or here. The process ID of this one, the P3 is the 18451. Who is the parent? C#. I logged in with the C#, that is login ID, this one. This one is actually served by the SSHD. I used the secure shell login. So that is the 18366. This one is created by another SSHD, another SHD. This one is created by the init process. Okay? So using such a hierarchy, finally this is the current process. So you can understand. And you can sometimes figure out the problem and issues and so on. So this is the same thing in your Windows. Windows provide such a command, and think that you need to install something different. I don't know the Windows 10 yet, but the previous Windows you can. This is a process, a PS list command. Then you can check this one. So in other words, each process should be managed by current process ID, PID, as well as parent process ID, PPID. So you should keep one. Whenever you are created, the process is created, this always need the parent. And also when you terminate, when you are done, you need to inform to the parents. Right? Very nice. Right? Very nice, children. Then when you are done, you can just terminate the process. Abort means forcefully. Okay? Sometimes it's called kill in the operating system. Here, abort the process, mostly terminate, gracefully terminate. At that time, parent, you need to inform to the children, to the parent, that is a wait system port. Wait system port will be managed in the process table, the PCB. Okay? So parent process will check whether status is the changed, terminated or not when the wait is executed. So there are different levels of the termination. It's called the kill different. So minus the 1 through 15, 0 to 15. Then you probably use a lot kill -9 and process ID. -9 is just kill. What happened? Just terminate, falsely terminate. Okay. Then kill means it's kind of interrupt signal. Okay, it's a signal. You send the signal to the parents. Why don't you forcibly terminate your children or the operating system if there is no parents? Okay? There are two types of there are unexpected status of the children process. One is a zombie process. Another one is an orphan process. The normal case, you can just inform to the parents, then I'm dying. I'm done. Then parent process, no. Then resume the current status. However, during that time, between this time and this time, once you inform, send the wait signal, then parent receive that signal, there's a short amount of time. Okay? Process exists. Existing means what? It occupies the memory. Okay? Momentarily. So it occupies memory, but nothing do. Because it's done. Instruction is completed. So nothing done, but so in the process list, there exists. Okay? Moment of time. This is called zombie process. Why zombie? Because nothing to be executed. No instruction, but in the process list, so there exists. So moment, so it's not error, okay? It's natural in any operating system. But any process should be little bit time zombie process. But rarely, so hacker use this one, so create a lot of the zombie process. Even though you could create a lot of zombie process, but doesn't occupy the memory. It's okay, but PCB, process list, this structure will be full. So you cannot create more processor, which means your system will be hang, stop. Okay? That's one of the way how hacker attack the system. So using zombie. And orphan means, it's not really orphanage, but orphan means the last one. Okay? Orphan means the parent is terminated. When parent is terminated, all the children process should be terminated. Cascading. It's a cascading termination. Because parents is dying, all children should be dying together. I don't think that's fair, but in the process should be. Sometimes there is a process. Children process without parent. There are two types of this. One is demon. Demon is a natural. No parents. Parents is one. Okay? It's a service program. It's a background program. Even though you log out the system, it's still running. That's the daemon program. Like the SSHD. Something D is usually daemon process. So only init process take control, such a daemon process. Another one is orphanage. Orphan process means unexpectedly parent is die. Still, this one is running, nobody take care. Okay? It's a waste of your resource. Okay? So in this case, the init process should kill or terminate falsely. Such an orphan. Orphan is a waste of space and waste of your resource, so your system will be downgraded. Okay? So that is the difference between the zombie and the orphanage. Zombie is natural, usually, mostly natural. So it's momentarily, so it's on the process list, but not in the memory. But the orphan process is occupied, it's running, okay, without control. It's not under control, so it's just a waste of So next class, we will talk about the best part of the process, mostly the communication. Okay. Then the thread will be finished the short. Then we will have the second exercise. Why don't you submit your 1 and 102 or any introduction of the computer science? Because of that, I believe that you are very familiar with the computer organization as well as the process. So what is a process? So what is a process? What happened? How can we use the computer resource? How can we use the computer resource, such as CPU and other display hub? So, Jengyu, why don't you hold on? Please hold on. Okay. So, how can you use the computer resource? Okay. Any idea? How can you and me communicate?
English.
They're using the language, right? Common language. It's the same thing. Computer cannot understand our natural languages, such as English or any other mother tongue, or any body language. No. Instead, we need to use a very specific, organized language. So unfortunately, most of the students and most of people are not very familiar with the machine language. Each can be understood by the computer. Computer can understand only the machine code. Okay, 0 or 1 combination. In the microprocessor class or the embedded operating system, embedded system class, you probably learn about the assembly language, mostly MOV, MOV, and one of the questions in your midterm exam was, what is the binary code of the MOV, the register 1 to register 2, something like that, right? So nobody wants to do the headache, the processing. Instead, we are going to use human-friendly languages such as the C, C++, Java. I believe if you took the CS 101, 102 right now, you learned about the Java. Also, if you already took the OOP class, okay, Object-Oriented Design Project. What's the name of that? OOP stands for Object-Oriented Programming. So you probably learned about the C++. Are they only the languages in the computer? No, that's only 2 popular program languages. There are a bunch of other program languages. Okay, so using such a program language, we can code first. That's close to the human being, right? So then we need to change it, translate. Such as when you talk to your friend lives in the France. So you need to know whether you need to translate, whether you need a translator who knows the French and the English. Exactly same thing in the computer stuff. So when I when I ask the computer resource, you need to use the program language that should be compiled. What happens when you compile the program languages such as Java or the C++? What happens? You have
An object.
Object or executable file, right? So if we are using the Java, so it will create the class file. If we are using the C++ or other languages, most of the time it will create the executable file. Or if you are using the shell script, okay, shell programming, so it will be interpreted. Interpreter is also kind of compiler, but it will compile line by line, or sometimes interactively compile it. It's the same thing, exactly the same thing. So after you compile, what do you have? You have a program, okay? So program is what happens when you open the program. When you tear off the program or when you investigate inside the program, what can you see? The one children younger. And also that is the instruction. So it's nothing but the bunch of instruction. You can see the set of instructions. So if you have the special editor, like the hexa editor or the ultra editor, actually you can see the hexa number. That number represents the instruction. that you learned in your microprocessor class, that's the assembly language. Okay? Then finally, the CPU, your computer, whatever the computer you have, can understand the program, your application, what you want, what you ask to the computer. So then that is a program. What is the difference from the process? Are they same or the different process and program? What is the process? We have the program, okay? Sometimes I purchase, sometimes I compile, I made it by myself. So I have program then. It can be used by, it should be used by your CPU finally, right? So if your CPU can read the data, in other words, the instruction, that's it. Unfortunately, CPU cannot read the data directly from your hard disk drive. Because of what? We already discussed. Speed again. CPU is so fast, but your hard disk drive is too slow to support it. You cannot get the full benefit, even it takes a long time to learn the hello world even. Okay? So how can we address the problem? We can use the faster storage. Which will be the faster storage? Faster than hard disk drive. It's a memory. So always the computer science guys would like to use the cache approach to address the problem of the speed gap. We use a lot, whether or not you realize, we used a lot. Database used a lot of cache. And even CPU itself used the cache, okay, add to cache in the CPU chip. Okay, even your application used such a cache area to speed up. So same thing for the CPU. CPU need to access the instruction, not from hard disk drive, it's from memory. Okay, so we need to copy, we need to upload, we need to transfer all instruction in the hard disk drive to the memory. Okay, that is the process. Basically, inside the process, inside the program, both of them are identical. They have the same instruction code. However, sometimes we call program as a passive process. Passive. Why? It cannot do anything. It's a passive. Until the instruction is loaded to the memory, then it will be active. Active means they can do something as you coded, as you order to the computer. Then finally, that is a process. Then we can use the computer resource. That is the process. In other words, we can say everything on your computer, any computer, is a bunch of process. Without process, we cannot get the research, computer research, we cannot do anything. It's a bunch of the process itself. That's it. So which means it's very important to manage. So what about your laptop? Do you satisfy your laptop?
It could be faster.
So probably you did when you purchased it, but it's gradually slower. That doesn't mean your CPU is actually slower, right? In other words, on the other hand, so you have more process to that need to use your computer resource power. So we need to do something. We need to manage. We need to schedule. We need to organize. We need to optimize. That is the main purpose of the process management. So if you take a look at your textbook, half of that is actually the process management. That means it's very important. Okay? I/O management or memory management are also important, but comparing to other management issues, process is the most important part. So we will spend the first half of the semester, last probably 6 weeks, so to discuss about the process management. Okay, so somebody said in this textbook, even including the author of this textbook, use the job or the jobs to represent the process also. Okay, so if you can, it can be used interchangeably. It's a user program. It's also almost the same as the process, right? So it's an executable file. Whether or not you download or you create or you compile, it's a program. Or sometimes it's called a task. So they are the same meaning. but they are passive. They are not doing anything until it is executed, until they are loaded into the memory. So overall, so we can use the job or the process to represent such active program. So that is our goal to manage. So we can define a process as the what? It's a programming code loaded into the memory. It's a programming code in the memory. That is a process. How many processes we have? Many processes. That is the long time ago, old-fashioned the operating system sometimes can create only one process, one job, okay, one application, such as the DOS, the old. But nowadays, most of the operating system, but still there exists a firmware or the embedded operating system, embedded software that can create only the single, the job or single process. I'm thinking to offer the new project in the next or the 2016 fourth semester. That in that project we will create the very simple operating system with the Raspberry Pi or the Arduino may not be flexible, so I'm thinking of using the Raspberry Pi. Then we create the operating system. Operating system is not that complicated for educational purpose. As long as you can create the first process with a kernel, that's it. So as many of the such embedded operating system, embedded system has the single process, single job operating system. But most of them are the multiple processor. Also, in terms of the data structure, what is a process? Process is the memory structure, because anyway the program will be loaded into the memory. Okay, so we have a program. This is what? Is the what is this? I think I already asked you guys.
Computer.
It's a computer. In my class, always the rectangle represents a computer. So computer has something CPU and also the memory. Also, it has the hard disk drive. Our program is the here foo.exe. Okay? This is a program. It's nothing but set up the instruction. Then, if we execute, how can you? By the way, how can you execute the program? How can you create the process? It's the same meaning. Execute the program, or the running a program, running a job, or creating process. It's the same thing. Double click. Right? Or sometimes you can type command, as you have done in your last exercise lab. In the command line interface, you can type the command. You can use the terminal window in your Mac OS, or you can use the PowerShell, even Windows, you can type the command. Or you can double click. Then what happens? When you double click, or when you type command. If you do not understand, if you cannot answer this, you cannot do first project. One of the main tasks of the first project is this one. How can you create? Whether or not you can create the process. Okay? So when you double click, when you the type command and enter, you are currently using a process, right? Everything, every job, every application are based on the process. So when you are saying that I'm using computer, I'm logged in, I'm doing something with the computer, that means there is a process, okay? That support your job, or that are doing something on your computer. Mostly it's a shell program. Sometimes it can be application program. Okay? Sometimes you can directly use the operating system, part of the operating system, but mostly shell. For example, desktop on Windows, or the terminal that you use in the Linux. Okay? That will create the child process that is this foo.exe. We will see detail. Then it will be loaded into the memory. That is the process. Problem is how? How are we gonna upload? How we can upload? Can we upload the program into the memory? How? That is a problem of data structure. Okay, everything in the computer stuff, computer science stuff, it should be structured. It should be organized. Okay? Otherwise, the computer cannot understand, cannot do anything, even though that is a most powerful supercomputer. If that is not organized, no, they cannot do that, unlike the human being. Human being, even though not organized, so I can manage the student request or the something advising, we can do that, but the computer should be organized, which means it's a very detailed format. Okay, when you upload this, it's not just a copy. Okay, it's not just copy because hard disk drive and memory are totally different media. Okay, so for example, memory is nothing but what is that? What is the memory, by the way? It's an address. It's nothing but address. Okay, it has bunch of. It looks like the grid line. It has an address, 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 address. So each address there is a storage, small storage, so you can keep the data like the 8-bit, the 16-bit, the 32-bit, and what about this one? Hard disk drive has something different. Like if you are using the traditional hard disk drive, it has the CD-ROM style, the disk, and it has a bunch of sector and cylinder, and you can find the sector where data is stored. It's different. Okay, so we need to have something format. In other words, the data structure should be detailed. Structure, okay? Basically, it consists of the text area and programming counter, stack area, and heap area, and data section. Always see. Okay? Who defined the disk? Who defined?
The operating system.
Your compiler knows. Okay? Compiler knows the process structure. Then, in other words, your operating system, not actually operating system, your hardware provide the specification. Okay, this is a 16-bit processing. And the memory address organized by the 16-bit addressing format and something like that. And what 32-bit. And it used something specific instruction. Then your compiler knows such a structure. So default size of the processor is 32K, something like that. So it's a structure. So we will see more details about such a process data structure for the process. Okay. So this is a comparison between the high-level languages, okay, and it's a hello, nothing but hello world. It's hello. It's a print I. But if we compile this one, it's inside of your program. Okay. In this case, there is we do not specify the object file. The output it will be the default. Then it's inside. Some of them you are familiar with, but it depends on your processor. So these the instruction set of instruction loaded into the memory. That is basically the organized such a way. Okay, this is on the memory, which means there is an address. So address is from lower address to higher address. So it's a 0 to 32K, for example, or 64K, something like that. Then it consists of text area. Text area means programming code. Programming code means this one, instruction. It will copy the instruction. Actually, we do not, most of the operating system do not copy entire instruction at the first time. When you create the process, we need to copy load the instruction to the memory, but not all instruction. Why? Why we don't have to copy all the instructions? First reason, which one is bigger? Memory, hard disk drive? Definitely hard disk drive. Which one is cheaper? This one. So we can keep as much as possible. Memory, no. And also it takes some time to transfer. Anyway, it requires input and output IOs from hard disk drive to the memory. Then fortunately, do we need all the instruction at the first time? No, it will start from the main function and need next. Sometimes some of the block never been used, right? So idea is whenever we need the instruction, then load into the memory. So this the text area will not keep all the instruction together. Instead, whenever you on demand. So when you need, you can copy, reload the instruction. Then next part is from global area, global variable. What is a global variable? We have also local variable. The more global variable is better? No. Probably your instructor in your programming class asked you to not create the global variable. Why?
Can we change the subroutine?
Should be public, so accessible. Also, it consumes the storage area of your process structure. It's a very limited first time. So if you have many global variables, sometimes it's a limited. Okay. What about the local variable? Local variable will be temporarily used. Okay? If your subsection or the class is terminated, we don't need such a. That will be heap area. So this one refer the other memory spaces, so it can be grow up. Okay? So that is the heap, and also stack is a temporary purpose. What is a stack? By the way, it's a data structure you learned in your CS1 or 2, and what introduction of your computer science. So what it says stack? It's a step up. So when you step up your node, stack next. So then how can I access the laptop? We need to take out this one, then next. Then this is a step. It's a first thing, first one, last one. Okay? What's the different thing? Similar but different data structure? Queue. So stack and queue are very, very popular and very important data structure in any computer science. That is the reason you learn the stack and the queue at the first time in your undergraduate computer science major. Okay? Anyway, that is a stack. So stack will be used for the temporary space. So if you took the, what is that? Microprocessor class. So how can you temporarily save the register information? Using stack. You can put all the register information to the stack temporarily. Then copy another one to the, using what operation? Push and pop. Push all and pop all. If you do not remember, if you cannot remember that, why don't you spend a couple of minutes your old textbook or the Wikipedia that you prefer, so that you can understand. That is a stack and that is a heap. So these are the basic organization, basic structure of the process. So when you create the process, which means when you execute the executable file or the class that will be loaded into the memory with this format. Details are various depending on your operating system, depending on the computer architecture, like especially CPU. Okay, so that is the the local variable is temporary space. So heap area is a dynamic allocated, like the array. Okay, the array, dynamic array, so or the array or the full, so list in the or the vector in Java. Then each processor, since we have the many processors, but how many processor, how many CPU? Very limited. Okay? Sometimes one, sometimes two, but anyway, comparing to the number of processors we have very limited the CPU resource. So we need to manage. So to manage, so we are going to define different state of the process, which means one process, he is waiting for my advising. So he's right now meeting the, wait a minute, but he's waiting. So his status is currently meeting with the professor, but he is waiting status. But he ignore the process or terminated. So we have the various types of the student who are waiting for my advising. Similarly, we are going to define the process states. Some of them are running, executing, okay? Some of them are just waiting. We will see what wait. Waiting for what? Okay, we will see later. And ready and terminate, so different state. Depending on the operating system, some of the operating system provide more details, the status, or sometimes the others use the simplified, but mostly it can be defined as a 5 the process state. So we will see such a 5 process state. So once the process is created, that is called a new process state. So process is new, okay? Newly created. We will see how to create the layer, okay? Suppose that the process is created, so its status is a new process, but it's just the created. It's nothing happened, okay? That is a new state. Then, if everything is ready to get to ask the CPU resource or other computer resource, it will move to the actually ready queue. There is a queue. Queue is what? It's a first in, first out, right? It's a queue. It's the most common, the organization of the not only the data but the problem when you when you want to meet the professor, if there are a lot of students, it will be queue. Even though queue itself is not frequently used in English, I think the UK used a lot more such a queue. Anyway, this is a queue, but in computer science you should be familiar with the name of queue. Then, so this process actually entered the queue. For what? To get CPU resource. That is called ready queue. The process in the ready queue is called the ready state. Okay? So their status is changing. Then somebody may be curious, how can we manage such a different state? Okay? We will see later how we can manage the different state. It will actually answer is managed by there's another control block, another data structure that can manage any information about the process, which is called the process control block, PCB. Okay, we will see later. But go back to the process state. So ready queue has the process 1, process 2, process 3, like that. These are the process to be ready to get the CPU. Then CPU will select the first one. Yes, because it's a queue. But not always the first one. For example, process 3 entered the last. But it's very, very important. Otherwise, your system will be crashing. Okay? It will be down. So this is very, very important. So sometimes the CPU can select this one. Also, process 1, but if this one is always important, P1 may not get the resource, right? So there are algorithms, many different algorithms to select the proper process. Basically, it's a first in, first out. But depending on the situation or the policy. Do you remember the something policy? When you design the operating system, you need to decide the policy first, then how to solve that problem. So you should have the policy. So depending on the policy, one of the process will be selected. That is called running state. How many running the process? Only one at certain time. Because we cannot increase the CPU time. We cannot make the more the CPU, the physical resource. So only at certain time, we have only one running the process. That is but with the time slicing, okay, we can virtually have the active process, but physically it's only one, the running process. That is a running process. Then, what is the main job of the instruction? Okay? Not instruction, process. What can you do in the process? You can read and write the data, input and output of the data, right? That's one of the main tasks. Another one is calculation, process, okay, add, okay, or the something other operation. So, if you need such a CPU bound job, that's called the CPU bound, CPU operation, something the processor operation, then it will be keep running. However, if you have the I/O job, I/O bounded job, I want to read the data in this example, I need to read the data, integer I, which is in the memory. Okay. Eventually, it can be the hard disk drive if you read the data from the file. Okay. Anyway, you need to get such a data I. So at that time, you need to ask to what? I/O devices to access such a data. Okay. So what can you do during that time? So I requested him to bring the PowerPoint file in my office. Without them, I cannot continue my lecture. I should wait until he returns from my office. So it's the same thing. CPU, when a process, the running process need to access the data. In other words, if they need input and output, CPU must wait until this point. So if this is a CPU time, so CPU operation, but it's an integer I. So I/O. So you need to wait until integer I, the data is returned. So this time is the idle time. Then operation, CPU job. It's a waste of time, right? Don't you think? It's okay? Doing the I/O? No, nothing. So it's a waste of CPU time. So idea is, why in case there's an I/O, why don't we use such a CPU time for another process? Okay? To do that, we need to change this one to the waiting status. Waiting state. Then there's no running, so we can pick up the another process to the running state. Okay? Who is in charge of such a picking up the process? Your operating system. Okay? That is called CPU scheduling or CPU scheduler. Somebody called it a dispatcher. Okay? Who dispatch? Like dispatch the security guy. So we will select one of the process. How? There's a bunch of other algorithm policy. Okay, so in chapter 5, we will see CPU scheduling algorithm. There are different ways of the CPU scheduling algorithm. Okay, so then there is a process. What happened? What if the integer I is returned? This process wanna continue their job, right? Next instruction, because they got the returned data. At that time, this one cannot back to the running queue directly because somebody used CPU resource. Instead, it can go back to the ready queue. So this will be entering the ready queue. Then maybe pick up by the CPU scheduler later. Okay? So that is the ready queue again. Sometimes I don't have any the I/O instruction, I/O job. So I keep computing forever? No, you cannot keep all the time the CPU resource. So at certain point or certain time, for example, the maximum duration, the 0.1 CPU time, or sometimes I/O return, this time interrupt. Even though this one go back to ready, you need to inform to the operating system, I'm ready, I'm done to read the data. How? Using interrupt signal that we discussed. Interrupt is a signal operation to inform to the CPU that at the time it will go back to the, even though there is no I/O, it can move back to the ready queue. Okay? That is the ready and running. Also, what happened? You are done. Every instruction is done. Finish it. Then it will be terminated. So terminate. Basically, 5 different states. Any question? Then how can we? We need a queue for this one. Ready queue, right? Because we have many processes. Also, we need to queue for waiting I/O device for each, because we have the hard disk drive, we have a mouse, we have screen, okay, different I/O devices. There might be processes who wanna access the data from a hard disk drive. There might be many processes who wanna use the mouse. There might be multiple processes that wanna use the screen. Okay, so you need to manage also the queue for each I/O devices. Yes.
I thought the interrupt is when is something happening.
Something means, for example, you finish to read the
But
data.
even before that, like,
Mhm.
when the operating system is being run, and then, like you said, you need something else to be run. I thought that's when you interrupt.
Yes. So when you finish the job, who knows that disk controller, for example, any device need to be connected to the controller, right? Disk controller, USB controller, CPU controller, memory controller. That controller, the initiate, the interrupt. In other words, you can control a disk controller, inform to send a signal to your operating system. So I'm ready. Please consider me for the next time, CPU time. Okay? Then operating system stop and move current one to the ready queue. Then run CPU scheduling algorithm. Okay? Then pick it up one of the process from the ready queue. And also we have the queue for each device. Okay? So the queue and the algorithm is called the scheduler. So scheduler means it's a process, it's an algorithm, and also can be implemented by your program. Also, it's a part of your kernel program. So if you have a better idea and perfect idea, you can implement your algorithm, how to select a process. Okay? Then implement using C or the C++, then add your program to the kernel, current operating system. Then you can rebuild, you can enhance the operating system. That's the way of improving or developing the operating system nowadays. Okay, any question? That's one more thing. I need to little speed up. So then, what about this one? how can we manage? Do I need to put all the data structure instruction to the ready queue? No, you don't have to do that. It's already in the memory. Instead, what we need is in this queue, in this process state, do we need all the information about the process, including data, global variable, or the local variable, or heap data? No, we don't need. Instead, the process information, including process state, process ID number, and program count. What is the program count?
To tell the program, tell the computer go to the next thing.
That is the address of the next instruction. I think that when you took the microprocessor class, so you learned about such a programming counter. It's the address of the location. So usually offset, relative address of the next instruction. Also, each process, when let's say this is the CPU, and it has a register 0, 1, 2, register information. Okay, A, B, AX, BX, something like that, right? So, what about the process 1? Process 1 use the CPU, then go back to ready queue. Next, processor 2 is selected. Processor 2 has the same information on the register. No, it's totally different. They don't need, process 2 does not need this information. So throw away the process 1. So when P1 is back to the CPU, does it need to calculate all of them again? No. Instead, when P1 is go back to ready queue, why don't you copy the current image of the register? Is it huge? No, actually it's not huge. Register is a very small size compared to others. So we can keep in such a data structure. And some others, like how many files, which files are opened by that process. So we can keep such only the process information in the PCB. By the way, what is a PCB? It's also data structure. It should be defined in your programming when you develop your operating system. For example, this is an example of the PCB in the Linux. You can see bunch of, it's a structure. It's a struct. Okay? It's a data structure design. For example, it has the, you can see long data type for the state, and the long data type for the counter, priority, and signal, and so on. Okay, it's a header information. Then source code you can find in your Linux. It's an open source operating system, so always you can find the source code of this one. Okay. Then how can we use such a PCB? It can be used for the process. Process 1, move up, then process will take over the CPU. This is called context, the switch, CPU switch. Also it's called the context switch. So we switch all information about the CPU for the new process always. This is called, how it works, it's simple. This is let's say we are going to explain the context switch or CPU switch between process 0 and process 1. Current process is process 0, next new process is process 1. Then at this time, the stop. How can we stop? Interrupt. Or sometimes it needs IO. Then it's a stop. Then copy all the information to the PCB of the process 0 by following this structure. Okay? So including process state. Process state is current, it will be, because of IO, it will be wait state. Okay? Then the process number will be the process ID 111. That's like that. And keep all the information about the process 0 to the PCB 0. Then after complete and bring the PCB of P1. It's on the operating system. So operating system manage the PCB of P1, then copy to the CPU register and keep in the running state. Then same thing if this one is done with the IO, then get back. So 2 times of the context switch in this case. Question. This is a time. What about this one? Is it good for the system?
No.
It's a waste of time. Okay? Can you avoid such an idle time? No way. It takes a time to switch. So context switch or the CPU switch is the overhead of your system. The more context switch, the better? No. In terms of performance, not good. Okay. So this is also the key point, how to enhance the performance of your system, how to reduce the number of context switch. However, if you reduce the context switch, it's good for you always? No. It cannot be fair with all the process. Your multitasking degree will be decreased. Okay? Because you have less number. So you need to optimize your operating system manage the proper number of context switch. Also, try to minimize the information about the PCB. That's the key point. Okay, when you design the system. Okay, so this is an example of the PCB used in the Linux. What is a thread? Thread is the string, okay, long line of string. So thread means, I think that you probably heard about the thread. What is a thread in computer science? It's kind of process, but slightly different. If they are the same, you don't have to use. How different? Thread is basically sequence of instruction. We can consider sequence of instruction. We cannot process the 2 instructions at one time, so it's a sequence of the series of the instructions. So traditional computer architecture allows 1 thread per process. But nowadays, we can process. So in the traditional system, thread can be nothing but the process. Process is one thread. But nowadays, we have multiple system. Also, we have the multi-CPU system. Even we can consider, okay, multi-thread for the single processor. Okay, so it's a parallel, or the function, or class. Especially Java use basically thread instead of the process. We have the Java application running on where? Virtual machine. Okay? Virtual machine manage what? Thread. So everything running on the virtual machine is a thread. Okay? That is the reason. If we consider such a Java thread as a process, it looks like the operating system. So somebody regard the Java virtual machine as a type of operating system. Okay? That makes sense. So that is the thread. We will discuss more details in the next chapter. Nowadays, thread is getting important. Okay? That thread information in also PCB. Okay? So then this one, the more important thing. After you understand the different state of the process, how the process is executed and change their state, then key problem is how to select the processor from the ready. Okay? How to manage the job. Job means number of application, number of entire process. Each process will be selected. So scheduling problem. So that is the reason in chapter 5 we will discuss about the scheduling algorithm only. Okay? That determines the overall performance of your system. So process need such a scheduling algorithm. There are 2 types. First, before that, in case we have the queue, then we need to have the scheduling. Instead of just a first in, first out, sometimes depending on your policy, we need to select other process from the queue. So what kind of queue we have? The ready queue. And each device, also we have job queue, consider entire process in your system. Okay? Only process that select can access the ready queue. So we can consider we can classify such a scheduling algorithm into two parts. That is the short-term scheduler and long-term scheduler. First, the long-term scheduler means it's a long-term. How long? 1 year?
No.
2 years? 1 second? 1 hour? No, it's less than a second. Okay? Select the process degree of your multi-programming. How many processes? So when you see the task manager or other monitoring system of your operating system, you can see active, right? Not all active processes are getting CPU resource. Only few or only one of them. But it shows the active. That active means selected by long-term scheduler. Okay? But long does not mean the 1 year or the 1 hour. It's usually 1 second or even less than a second. Then, among that, the active running, not running because we have running queue. So, among the processes selected by the long-term active process, they are in the ready queue. Okay? Then, one of them need to be selected to get the final CPU resource to be a running state. That is the short-term scheduler or CPU scheduler. How short? 0.1 second? No, usually millisecond or sometimes microsecond. Okay? So that is the why. Think about the CPU speed. The 2.0 gigahertz means what? 2 giga times of CPU cycle. So in one cycle, you can process one set of the instruction. Sometimes one instruction needs 2 or 3 cycles. Let's say 2 cycles. On average, the one instruction needs 2 cycles. How many instructions can you process in a second? 1 giga. Okay? 1 giga of the instruction you can process. So 1 giga. Even millisecond is huge in terms of the CPU time. So short term means it's a millisecond, sometimes microsecond level. Okay, this is the short term scheduler. And from new to ready is the long term scheduler. So there are the two. We are going to focus on the short term CPU scheduler in this class. So in chapter 5 we will see how to schedule. Then mostly long-term scheduler determine the degree, how many the current active process. So if you want a high degree, which means the more process are active, you can increase, you can change such a long-term, but mostly not. So customize this one. Even the short-term scheduler is not customizable, but that's critical to determine the performance of the process. But by the way, even though we have the perfect, nice CPU scheduler, this is a CPU time. Can we increase, stretch out the CPU time? We cannot change the time, okay? Unless we have God, right? The time cannot be shown. Time cannot be stretched out. Okay, time is a time, right? Our goal is maximize the utilization, 100%. Actually, 100% in terms of CPU time is not good. Why? What happened when you check your CPU time? You're using the task manager. It's 100%. That is good for you?
No.
Mostly not. Mostly it's a infinite loop or something wrong. Why? Do you remember dual mode of operating system?
Yeah.
Dual mode means user mode and kernel mode. So they need to use the CPU resource. But 100% is user mode. In your application, Without system call, it's just an infinite loop. So no chance. The kernel thread to get the CPU resource. That is the reason 100% is not good for your the operating system. You need to be balanced. Mostly 3-to-1 or 2-to-1. So 60% and 40%, or 70% and 30% should be balanced. We will see the example during the exercise lab problem. We can monitor. And okay, so how can we maximize? Idea is there are two types of processes. One is actually it's an instruction. One is I/O. Need the I/O. You need to access device. Another one is CPU operation. So CPU operation need to continue the CPU time, but this one does not need. So using context switch, we can select the process that needs only the CPU time. That is the idea of the scheduling. Okay, so this is the overview of the process scheduling algorithm. Okay, so we have the long-term scheduler here. Then, if that is selected from the ready queue, we need to select the one process to be running state. That is a short-term scheduler. And also, after that, we have each I/O device has the queue, as we have seen over here. Okay. Sometimes some of the operating system provide in between the long-term and short-term. That is called the medium-term scheduler. It's not very critical. So as long as you understand the long-term and short-term, short-term is more critical to get the CPU resource. Then it's fine. So that is a scheduler. So we will see the details of the CPU scheduling algorithm in chapter 5. Okay. Any questions so far?
It's a logic process.
A little bit speed up comparing to the previous semester because I add 5 times, 6 times of the exercise lab. That doesn't mean I can reduce the contents. Okay, so I need sacrifice your time. So even though I speed up, I'm not going to take out the part of the content. Okay. What about the mobile system? Nowadays, mobile system is getting important. What's the difference? This one and this one.
That's mobile.
Size. Actually, basically, it's the same computing architecture. It's a computer. So my daughter, she still believes the smartphone is something different and special thing. But when I say your iPhone is the same as my computer, then she doesn't believe. It's the same thing. It has a CPU, it has a memory, it has a hard disk drive, but different hard disk drive, right? So, and it has a screen instead of mouse. It's a touch chip, so it's basically the same architecture. Then also, however, they need also operating system, but operating system create the process. It's the same thing also. But what will be the main difference between the desktop computer, laptop computer with your smartphone? Nobody wants to keep connecting your power source to your smartphone. Why? Because due to the nature of this device, it's a mobile device. It's a mobile. So nobody wants to connect every time. I was surprised when I visited China last time. Many of the students actually bring another box that is a rechargeable, the battery. So main difference is the power. Even this one, not many people satisfied with. I want to keep this one to the classroom and the cafe and the other thing, but so you need to recharge. So, but you don't want to keep connecting, so it's a tedious job to connect. Whenever you come to the classroom, connect to the power outlet, okay? But still, you can keep the power up to nowadays 6 hours, but it will be the lower. What about this one? So you get tired. So whenever you travel, so you need to find the power source in the airport terminal, right? So that is the main thing. So actually people in the manufacturer, Samsung and Apple, they spend a lot of time how to minimize the power consumption. It's the same thing in process management. So that is the reason all the fashion, the mobile, the operating system, they allow only one process active. The others is a deactivate. Only one process. Okay? Because of that, it is not still possible. Some of the Android allow multitasking, okay, but only one process at a time. Two, because of the power consumption. But nowadays, the current, including iOS and Android, they allow the foreground is one, so they allow background process. It was only one process in total long time ago, but nowadays they allow only one foreground process. Still limited the multitasking, but they allow. What is the difference background and deactivate? You can still keep the process in the memory, okay? But it doesn't use. What is the main power the consumer of your mobile device? It's a screen, okay? I think the more than half is of your power is the used by your screen. So only one foreground means occupying your screen. The others are considered as a background. Okay. So we already discussed about this context switch. Then finally, how can I create the process? That is your first project task. Okay. In your in your project, you need to develop the shell, your own shell, UBOS. I named it UBOS. In your shell, your shell should be able to create the process. How can we create the process? We will see. So before that, we need to see the basic, the concept of the process. Most of the process, like the tree structure, which means we have first process. What is this first process? It's the kernel. Okay. Why don't you remind? So if you do not believe that your memory, why don't you spend a little bit time each and every class to review the previous class? The kernel will be loaded into the memory. That is the booting your operating system. Then, usually it's called the init process, initial process, whatever the name is. Sometimes the process, we assign the process ID. So do you remember our PCB structure, process control block? The top part is the process number, process ID. Your operating system, though, does not care the name of the process. Instead, it will be managed by the ID, process ID. It's the same thing. File. Your file name, doesn't matter. The file descriptor, file ID is more important. Your username is not important. Your user ID, okay? In the last exercise slide, I showed the UID and the group ID. That's more important. That's the reason when you connect the network device, network file system, how can operating system check, OS check, the same user? Only using ID. Doesn't matter if it's a J or Lee, as long as ID. It's an ID. Then this always, your processor will be created by existing process. So, which means init can create the children processes. Like in this case, the login, kthread, the SSHD. Mostly these processes will be system process. So when you're booting up your operating system, it will create the default processes, sometimes the services, okay, which you don't know sometimes. You can set up, but most of the time you don't know which one is which. That will be used for service, like the secure shared or the thread to create a file or login. So it's mostly the system function system, the processes. Then also this process will be created by this process and so on. This is the nature. This is the only way to create a process. Okay, parent and child, parent and children process. Finally, so I logged in. Then when I log in, when I type the terminal, when I double click the terminal, this process request receive my request. Then create a child process that is the BASH, batch shell. That is your shell you use in your last exercise like that. If I type the PS, it will create the PS, the process. If I type the Emacs, Emacs is the editor. VI edit is like the VI editor, but Emacs allow huge size of the file, like the 1 gigabyte file. You can actually open that one. Emacs will be created as a child process. This is a basic architecture. So it's always a tree structure. What about the Windows? Windows has the same architecture. It's a process structure. Okay, then there are 2 steps when you create the process. Windows, same. Linux, same. Even though name of system call are different, it's the basically same thing. First, when I create, I'm not sure whether that is the same mechanism as the human being or the other animal, but the process can create the child process. First, copy. Okay? Exactly copy as mine. Okay? Same thing. Copy. Similar in terms of DNA. But the human DNA need mutation. That's the reason children may be different. But in process creation, creating include 2 steps. First step is copy, clone. Okay? They share even code part. What is the code section? Instruction. It's the same thing. When I type the PS command, when I type the word process, it doesn't matter where you are. It's just copy exactly in the memory. Okay? Even code part will be shared. Which means in your memories, so this is your current process. Then this one has the data, this one has the global variable, heap, and stack. And copy. Exactly the same thing, but this part will not be created, just the share with this one. It's a new process. This is called fork operation. First, fork. Okay?